For this lab number 2, we will be taking a closer look at the principles of electrostatics. Electric charge is a fundamental property of matter that gives the rise to the forces of attraction and repulsion between objects. The study of electricity helps us understand how charges are created, transferred, and influenced by nearby materials. Objects can become charged in several ways, including friction, such as rubbing two materials together, conduction, a direct transfer of a charge through contact, and induction, which is charging an object without direct contact, often through polarization. The purpose of this lab is to explore different charging methods and observe how charged and neutral objects interact under various conditions. This experiment is significant because it demonstrates the underlying principles of electrostatics hands-on, reinforcing theoretical concepts with observable interactions. It also highlights the role of a charge transfer and polarization in determining whether objects attract or repel one another.
Here are the materials we used in our experiment. An electrometer to measure the presence and sign of charge with a Faraday cage. 3 rods, acrylic, glass, and PVC, each rubbed to gain different charges. 3 cloths, fur, silk, and wool, used to transfer charge to the rods. A pith ball on an insulating thread, representing an isolated conductor. A piece of dangling aluminum foil, acting as a grounded conductor. A grounding source, like a hand or earth ground, to allow electrons to flow. For our induction portion of our experiment, we used a conducting spheres. And a glass rod charged by fur cloth.
For the first part of the lab, we rubbed the acrylic rod with the fur, then checked the charge for positive or negative, then neutralized it, then repeated the process for silk and wool. We then did the same for the glass and PVC rods L. For part A, we charged the glass rod with wool and brought it close to the dangling tin foil, and we observed an attraction. In part B, we touched the dangling foil with the same recharged rod, then separated and brought them together again. We then saw the two objects repel. In part C, with the isolated pith ball and the same recharged rod, we brought the rod close to the pith ball without touching. We then saw an attractive force. In part D, the pith ball gained a net charge through conduction because we recharged the same rod and touched the pith ball, then brought the rod close to it again, and same the pith ball repel. For charging through induction, we brought the same recharged rod close to two touching spheres. We then separated the spheres and checked the charge of one sphere, then the other, which we saw on sphere be positive and the other negative, demonstrating charging by induction.
Now I will go over the data analysis for lab number 2. In this lab, we first had to set up a table regarding the various charges we observed with 3 different rods, one of acrylic, one of glass, and one of PVC, when they were charged, that is, rubbed against certain materials such as fur, silk, and wool. In this case, we observed acrylic be positive with each material, glass be positive with each material, and PVC be negative with each material, as we put each of these rods next to the cage that connected to the electrometer, that way measuring the charge. We ended up utilizing the glass rod charged with fur, which according to our table was a positive charge. We utilized this rod for every single one of the following parts. And starting with part A, we first used a dangling piece of aluminum foil, which was grounded. Since the foil had not come in contact with the rod, it was to remain neutral. So we predicted that once we placed the rod next to aluminum foil without touching, we would observe an attraction, which was eventually confirmed to be the case. B, we used the same materials, that is the glass rod and the aluminum foil. However, we previously touched the aluminum foil with the glass rod. Now, following certain principles, we would know that Since it was touched, the aluminum foil would acquire the same charge as the glass rod. However, this piece of aluminum foil was grounded, meaning that since it's a conductive material, it would conduct the charge elsewhere and remain neutral. So we would see the same attractive force as we observed with a positive charge object and a neutral object. This ended up being the case as a dangling piece of aluminum foil was attracted to the rod. See, we utilized a pith ball, isolated, not grounded, as opposed to the aluminum foil. This ball was to be neutral, so we expected that it would be attracted to the glass rod, positively charged. This observation came up to be true. D, we follow the same procedure as with part B, that is, charge the glass rod, place it and touch the pith ball with it so it becomes charged. However, the important distinction is that this ball is not grounded, so it will retain the charge of the glass rod once it was touched. So we assumed and predicted that it would experience a repulsive force as it was positively charged as well as the glass rod. The observation confirmed this prediction, as we saw a repulsive force with the ball dangling in the opposite direction of the glass rod. E, we place two conductive spheres together, and then we place the glass rod close to it but not touching. This way, both spheres would be charged with conduction, as a negative charge would be placed on the sphere closest to the rod, and a positive charge would be placed on the farthest ball, as the rod is positively charged. Then we got the spheres to stop being in contact with each other, checked their charge, and confirmed with the electrometer that they were effectively negatively charged and positively charged according to our predictions.
In this lab, we explored different methods of charging objects and the interactions between charged and neutral conductors. We predicted and then tested how both grounded and isolated objects would behave when exposed to a charged rod. Overall, our results supported the main ideas of electrostatics. Polarization leads to attraction when a neutral object is brought close to a charged one, while conduction transfers charge and produces repulsion when two objects of the same type of charge interact. In Part A, the grounded aluminum foil was attracted to the charged rod due to polarization and the grounding effect. In Part B, after contact, the foil repelled the rod because it acquired the same type of charge. In Part C, the isolated pith ball was also attracted through polarization, while in Part D, touching it caused the same kind of charge transfer and repulsion. Finally, in Part E, we successfully charged a neutral sphere positively by induction, demonstrating that grounding allows excess electrons to flow out, leaving behind a net positive charge. However, several errors could have affected our experiment. First, the charge on the rods may not have been strong or consistent if they were not rubbed evenly with the cloth. Second, the aluminum foil or pith ball may have been swinging too much, making it difficult to tell whether attraction or repulsion was occurring. Finally, touching the objects accidentally could have discharged them, changing the results. Despite these possible errors, our observations confirmed the expected principles of charging by friction, conduction, polarization, and induction, providing us with hands-on evidence of how charges interact in predictable ways. For credits, Aaron completed introduction portion, Pedro completed the materials portion, Mark completed procedures portion, Seth completed the data analysis portion, and Gio completed the conclusion.